Hey everyone! In this video we are going to dive into a web scraping project, and for this we will be using this website Capelli Sport as our target page. The goal is to extract product information from the clothing section of the site. Specifically, we will retrieve the product names and their corresponding prices. Web scraping is a powerful tool that has a wide range of use cases and applications across different industries. By automating the process of extracting data from websites, it allows us to collect large amounts of information that would be time consuming to do it manually. And to complete this automation process, in another video we will incorporate the code we will write here into a web application. Alright, and just to mention some of the use cases of this technique, we have companies that would be interested in monitoring competitors' pricing, or just to do market research by scraping data about products, reviews, and customer feedback. Or real estate, web scraping is commonly used to collect data on property listings, housing prices, which are then used in market analysis or to feed real estate platform. Or the governments or agencies might be interested in measuring inflation, for which they use web scraping, and there are many such use cases. In case you are not familiar with Python or don't usually work on this type of project, I will provide you this link right here, where you can install Conda, which is a useful tool for managing Python environments and packages. So according to your operating system, you will be able to install Conda easily. The installation process is really easy, and you will just need to follow the setup wizard by clicking next a few times. And having this installed on your setup will not only be useful for this specific project, but also for other future projects that involve working with data, machine learning, or any task where you will need a flexible and isolated environment to run different libraries without conflicts. And now to check if Conda is installed on your system, you can use the following command in your terminal or command prompt. And this command will display the installed version of Conda if it is installed correctly. And now let's write the command that will create a new environment for our project. So it's Conda create the name of your project, that's up to you, and the Python version. Then you press enter, and after pressing enter, this installation will take some time. The installer will download the setup necessary to create your environment. Proceed, we press yes. And once the installation is complete, you will see a success message here near your terminal. Keep in mind that installing this Miniconda will be useful not only for this current project, but also for any future data science project where Python is needed. With Conda, you can easily create isolated environments that will allow you to install all the most popular libraries such as pandas, scikit-learn, TensorFlow, etc. And here you will manage the dependencies. After the installation is finished, you have to activate the project you already installed, and for that the command is conda activate Capelli is scraping Capelli. That's the name of the project and then we press enter. This line indicates we are already into our project. That means we can install now all the packages and libraries we we need for this project. And these are the libraries we need to install: pandas, request, lxml, beautiful soup, seaborn, scikit-learn. And we will see later what are they for. For now, we will press enter. And finally, after the installation of the packages is complete, the last command you will have to run is Jupyter Notebook. This is the application where you will run the code for the project. And after running this command, the Jupyter Notebook application will automatically open in your default web browser. Alright, so this is the finished project, and I will proceed to explain what I have done here. As I pointed out before, web scraping is a technique used to extract data from websites automatically, and this is especially useful when you need large amounts of information from a site that does not offer an API, or if the API is limited in scope. By scraping a website like Capelli Sport, you can gather product details such as names, prices, descriptions, which can be helpful for market analysis, price comparisons, or even building your own applications that rely on this data. So these are the libraries we installed earlier, and now we are importing them so the project can use them. Each library serves a specific purpose, like handling HTTP requests, parsing HTML, and organizing the scraped data. The request library is used to send HTTP requests to the website and retrieve the HTML content of the page we want to scrape. It simplifies the process of making GET requests and handling responses. Then Beautiful Soup helps parse and navigate the HTML content we retrieve. It makes it easier to locate and extract specific data like product names or prices from the HTML structure. And then we have E3 that provides tools for locating HTML elements. And then Pandas is the most popular library that is used to store and manipulate data in a structured format like tables or spreadsheets. That means that after scraping, we can store the extracted data in a data frame, which allows us to organize, analyze, and export in various formats like CSV. And now, after completing this part, something to clarify about Jupyter Notebook is that it works with cells, where each cell can contain a piece of code or text, and after inserting the code you need into a cell, you have to press run to execute that code. And once the code runs successfully, you can move to the next cell to continue writing more code. This step-by-step approach allows you to break the project into smaller parts, making it easier to test and build as you go. I won't be doing this step myself because I have already the project completed. So if after pressing run the program allows you to move on to the next cell without any issues, it means everything is working correctly, so no errors were encountered and you can continue building your project without any problem. And now in this line is where we send an HTTP request to the specified URL we want to work with, which is the women's section of Capelli Sport. So at first the scraping will be done on this section of the website where all the products are listed together. There are a few products on this section, and after that we will move to another part of the website that includes pagination and has a larger quantity of products, and this will allow us to cover both simple and more complex scraping scenarios. This is a simple scenario because there are just not more than 10 products here, so the process will be a little much more simple than if there is a pagination and more than 100 products. Alright, so after sending the HTTP GET request to this URL, we retrieve the HTML content of the page, and the response will be stored in the response variable. This will allow us to access the page data for further scraping. And next, by including this line in our code, we want to check the HTTP status code returned by the server. This helps us verify if the request to the website was successful. A status code of 200 means that the request went through correctly and we received the HTML content we wanted. Alright, so after these initial steps, it's time to start the web scraping process. The first scraping will be done on a section of the web page where there are only a few products, as it displays featured items. We'll begin by extracting only the product titles, taking it step by step gradually to build our scraping process. And what we are doing in this part of the code is to retrieve the web page and parse its content to extract product titles. And for that we use an if statement to check if the request was successful, and if so, then we print the titles. And the key to obtain those titles lies here in locating the specific HTML elements that contains the data you want to extract. Every web page is built with HTML, and information, whether it's product titles, prices, images, is structured within various tags and classes. And in order to extract the data we are looking for, in this case the titles, we have to inspect the web page source code here, identifying the relevant HTML elements. For example, in this case, the product titles might be wrapped in div or span tags with specific class names. And the question is how we access the element that represents the product title. And to do that, we have to right click on the product title. If you right click, then we select inspect, and this will bring up the developer tool panel, and in this panel the HTML code related to the product title will be highlighted, and this class grid product title is what we want to target, is what we have to target, sorry, in the scraping code to extract our product titles. And once we capture that HTML element that contains that title, we can begin with the code. And this is what we are doing here. We first check if the request to the web page was successful by verifying if the status code is 200, and if the request was successful, it used Beautiful Soup to parse the HTML content of the page. And parsing means transforming the unstructured HTML data into a structured format that can be easily navigated. And in this case, the HTML content is converted into a Beautiful Soup object, which allows us to search through the different tags and elements. So the function Beautiful Soup, this here, ensures that the HTML is parsed using the LXML parser, which is fast and robust for web scraping purposes. This step is very important because without parsing, the code would not be able to properly interact with and extract data from the web page. And after parsing the HTML, the next step is to extract the specific data we are interested in this case, product titles. And this is done using Beautiful Soup's find all method, which allows us to search for and retrieve all HTML elements that match a certain tag and class. In this case, the code is looking for div elements with the class create product title, which is where the product titles are located. So find all, this method searches the entire parse HTML for any div elements that have the class create product title, and it returns a list of all matching elements. And once all the div elements are found, we use a for loop to iterate through each one and extract the text. So here we handle the extraction and display of product titles while also managing possible errors. So first, with this if condition, we check if title elements contains any elements, and if there are products title found, the code proceeds to display them. And then if title elements contains one or more product titles, the for loop goes through each element in the list. With this getText method, we retrieve the clean text product name inside the div, removing any extra white space. And this is how the extracted title then is printed to the console for the user to see. Then if title element is empty and the scrapper cannot locate any title, we display no title elements found. Note this is a nested structure with an if statement inside another if statement, which creates a nested conditional logic. The outer if statement checks if the request to the web page was successful, and the inner if statement checks if product titles were found in the parsed HTML, and if both conditions are true, the code extracts and prints product titles. If either condition fails, the code provides helpful feedback for troubleshooting. And now that we have extracted the titles from the web page, this is where you can see all the product titles that were found within the HTML structure. Each title is printed to the console, so you can compare the output with what you see on the actual web page to ensure the scrapper is capturing the correct data. Here you can compare, and you see by comparing the scraped title with ones displayed on the site, you can verify the extraction process is working as expected. Alright, so as you see, this is what web scraping is all about: locating the relevant HTML elements and then using programming, as we are doing here, to extract the specific data you need. Alright, so as I mentioned earlier, this is just a starting point. This part of the process serves as an introduction, as we are scraping a section of the web page where there are only a few products. And since there are not many items, it's easier to manage and understand the flow of data extraction. If we continue, I follow the same process to extract the prices using two different approaches. However, I will not go into detail about that, as you can explore it on your own later. What we are going to do now is to move on to the more complex part of web scraping, which is where there are many products displayed on a different section of the website. In this case, we are taking this URL, and you see in this section of the web page there are a lot more products, and the layout includes pagination, meaning the products are spread across multiple pages, and this makes the scraping process more involved, as we will need to handle multiple pages and ensuring that all product information is captured correctly. And for that we have to implement a more dynamic approach to navigate through each page and extract the data correctly. And just to give us an idea of how many items we are dealing with, we implemented a similar approach to what we used here in the beginning. And here we are getting only the titles, but we are seeing the titles just from the first page of the products. But this same structure and this same amount of items repeats across several more pages. Each page contains a new set of products, and we'll need to account for this in our scraping process, handling multiple pages in order to ensure we gather all the available product data, not just what is displayed on this first page. And we are going to aim for now, and what we are going to aim for now is not just to extract the titles, but to retrieve both the titles and the prices in the same query. And this will allow us to gather more complete product information in one go. And this is the code that prints the data we are looking for, both the product and their corresponding prices. right? And notice the amount of data we are dealing with. It's really a lot. And this is because the code is designed to navigate through all the pages, capturing the information from every product listed. And as a result, we are able to extract data from multiple pages. And first we start by saving in a variable the web page, the page where we want to scrap, which is this one. And then we set an empty list called all products, which is initialized to store the results. After that, we initialize a variable to track the pagination. And next, we initialize a while loop for pagination. The loop runs indefinitely until the scrapping is complete. And for each iteration, the code constructs the page URL by adding the current page number as a query parameter to the base URL. And then the code sends a GET request to the page URL using the request.get method. And if the request is successful, the content of the page is parsed with beautiful soup using the configuration we already explained earlier in the beginning. Notice that up to this point there has not been yet a need to search for any HTML elements. This part of the code is focused on setting up the base URL, initializing variables, constructing the page URL with pagination, and making HTTP requests using. And now this is the part where we start working with the HTML elements that we get from the web page. And for that we use Beautiful Soup to find all HTML elements with a div tag that have the class create product title just to get the titles. These div elements contain the titles of the product of the page. And then with the for loop we iterate over each div element found in soup.findAll method, and in each iteration the variable title represents one of these div elements. And for each div element stored in this variable title, then we extract through this method getText the content or the text inside the div, while removing any extra white space thanks to this strip true, leaving only the clean product name. And for all these titles that we obtain from this line of code, we create product title. We create a list called product titles that will contain all the product titles that we find in each iteration. And similarly for product prices, we find all the elements with the class create product price that we get inspecting the price. Oh, not this one, this is the page of the beginning. This price we inspect, and the div tag is create product price. And in this way we create another list called product prices with all the prices that we get from here. Then we set a condition that checks whether the product titles list is empty. and in that case we print this message. This indicates that the scraping process has reached the end of the product listing, meaning there are no more products to retrieve on the current page. And then this break statement exits the while loop, which stops further iterations of the loop. And then with this zip function, we combine two lists, product titles and product prices, which creates tuples where each tuple contains one element from product titles and one from product prices. And the for loop iterates over each tuple produced by this zip method, and in each iteration, title is assigned the product title and price is assigned the corresponding product price. And inside the loop, for each title and price pair, let's say, a dictionary is created with keys, title and price and their corresponding values. This dictionary represents a single product with its title and price. So what we are doing here is iterating over paired product titles and prices, creating a dictionary for each product that contains its title and price. Each dictionary is added to all products list, which collects all the product information scrapped from the current page. After doing that, we have to take care of the element that is used in the pagination control to indicate the presence of a link to the next page of results. And for that we will have to look for here, and we will inspect this part of the pagination, and the name is span with the class next. The name of the tag is span, is a span element with the class next. And with that information, we will apply the find method of the beautiful soup library that searches for the HTML content. In this case, it looks for span element with the class next. It's not anymore div. In this case, it's span. Span represents the HTML tag we are looking for, and class next specifies the class attribute of span. And the result of this is assigned to the variable next page, which means that if a span tag with the class next is found, next page will contain a beautiful soup object representing that tag. And then with this condition, we check if the variable next page is known, and since in this variable all the elements that we find are assigned to this variable, or since this variable contains all the elements that we find through this method, if no elements are found, then it means that there are no more pages to scrape. And if that's the case, we will print this message. And it means that the scraping process has reached the end of the pagination. and with break we exit the while loop. And with this line we update the page number to ensure that the next iteration of the loop fetches data from the next page, allowing the scraping process to continue. And finally, in this for loop, we print the product details, displaying the collected data after all pages have been scraped and processed. And we place this right at the end because since the script first needs to scrape all the data across multiple pages, the printing of results is logically placed at the end. This ensures that the all products list contains the complete set of data before it is printed. So this for loop iterates through each product stored in all product list, where each product is represented as a dictionary